Hello class, this is lesson 6-3 in your textbook titled How to Prove that Triangles Are Similar by AA, which stands for angle. When we were proving triangle congruence, we were not allowed to use AAA, but simply if we only have two angles and they're congruent, that's enough to prove that the two triangles are similar. So let's start with our first postulate. This is postulate 22. And it's called the AA similarity postulate. And it says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Pretty basic, right? So in this case, if angle J is congruent to angle X, and if angle K is congruent to angle Y, then I can claim that triangle JKL is similar to triangle XYZ. Okay, and this works out every time. You could try it on your own. If you just made up some angles of two angles in a triangle, and then you wanted to recreate another triangle with the same measurements of just those two angles, you would find that you would have two similar triangles. So let's go ahead and do an example like this. Using this new postulate, the AA similarity postulate. And what it says is, are these triangles similar? Okay, so I have two triangles. One's drawn upside down, but that's okay. If so, explain and then write a similarity statement. Okay, so I'm looking and I just need to prove that two of the angles are congruent. And right away I see that both of them have a 90-degree angle in them. They both have a right triangle, so they both have a right angle. So I can claim at the beginning that angle D is congruent to angle G because they are both right angles. Okay. But I don't know if they have another one that is the same yet. Okay, one of them has 26 degrees for one of its angles, and another one has 64 degrees. So why don't we just find what angle E is? I know by the triangle sum theorem that I can add up the three angles, and it should add up to 180. So the measure of angle E is the thing that I don't know, but all of those should add up to 180 degrees. And so when I move stuff around, I'm going to find that that angle is, in fact, 64 degrees, which is the same as angle H. So I can claim then that angle E is congruent to angle H because they both have the same measurement. So in the end, triangle CDE is similar to the other triangle. Now when it says to write a similarity statement, you need to make sure that you write this in the proper order. So if I'm starting with CDE, angle C actually corresponds with angle K. So that's the first one I'm going to write. D corresponds with G, and then E corresponds with H. And I can say that those are similar by the AA similarity postulate, but I'll just let you write AA. Okay? This is actually going to be a pretty short lesson. I have another diagram here. I want you to show that these two triangles are similar, and this time they're stacked on top of one another, so it might be helpful for you to draw them separate. I'm not going to do that right now, but you are more than welcome to do that on your own. And so I just need to prove that two angles are congruent to two angles in the other triangle. So I have this top triangle, and then I have the larger triangle down to the bottom. And I can already see that both of those angles are 52 degrees. So since the measure of angle ABE is equal to 52 degrees, which is also the same as the measure of angle ACD, then I can conclude that angle ABE is congruent to angle ACD. So we're not writing out formal proofs, you're just kind of giving me your own explanation. Also, I see at the top that both of them are sharing this top angle, which I'm just going to say it's angle A. So that's the same in both of the triangles by the reflexive property of congruence. And that's it. I have two angles. That's all I needed to prove that the triangles were similar. So I'm going to say that triangle, let's start with ABE, that top one, is similar to triangle. If I went A to B, I'm going to say A to C now, all the way to D. I'm going to go in the same order. And that's it. And this is by AA, similarity postulate. Okay? One more example, and then we're going to be done. I told you it was going to be short. This time I have kind of a bow tie diagram again, and I'm asked to show that SVR, so SVR is similar to UVT, to that triangle. So probably you already noticed vertical angles, right? So let's go ahead and write that down. The angle SVR is congruent to angle UVT because they are vertical angles. We know the vertical angles congruence theorem. Also, I have some notation that these two segments are parallel. So I'm going to say since SR is parallel to TU, I know that angle, and I can pick whichever ones I want, but I'm going to say RSV is congruent to angle TUV. So RSV, this angle right here, to TUV. Why? Because of the alternate interior angles theorem. Okay, so I have two angles that I've proved that are congruent to two angles in the other triangle. So I'm just going to state that in the end. Triangle SVR is similar to triangle UVT by the angle-angle similarity postulate. So this is all that we're going to cover. So I hope it was pretty clear and that you're ready to get to work when you come to class.